I have been overeating on snacks and things, so I've got to start doing my doing some push-ups and sit-ups. That's my plan for the next couple of weeks and months for my personal life. Anyways, welcome back. Today is the 29th. I want to review where we left off with this comparing data sets, and that is going to be mostly using standard deviation because that was introduced in the last lesson. And then we also have to kind of know this whole idea of when to use the different markers we have for the center of our data and then for the spread of our data. And I don't think I did a very good job last time of kind of emphasizing that. So, oh, Delaney, I'm sorry to hear that. I hope you're feeling better. How are you feeling today? Still sick or on the mend?
Yeah, a little bit.
Yeah, it's the time of the season, right? Like right now in my family, at my house, no one's sick, which is a miracle. But we've all been sick at least like twice in the last 2 months. So it's just like I'm amazed that no one's sick right now. So I'm just crossing my fingers. So a couple quick announcements. Let's see. Today we're going to do review of the last lesson, comparing data sets, and then also included with that the idea of standard deviation. Deviation. Tomorrow we will jump into the final lesson, like final new material. And let's see. We'll probably do a review on Wednesday of everything we saw in Unit 5. And then we'll try doing our test on Thursday. Now, I know that might seem a little rushed, but remember, the unit's short. It's only 3 lessons. Thursday post test. And then my thought was for the next 2 weeks, I still will be meeting um, every day at 10, like normal. And we'll use that time to just catch up for anyone who needs help catching up on any prior units or anything in Unit 5 or whatever. So we have 2 weeks before the month ends, and we can use that time to just wrap stuff up. Since Unit 5 is so short and we were already halfway through it, um, I don't think we need to review the whole unit for 2 weeks. We'll just do review today, see some new stuff tomorrow, review everything on Wednesday, and then do our test on Thursday. And then we'll have about 2 weeks left to finish up. So if you are behind or just need help on anything prior, don't stress too much. Just come join me every day like normal, and we'll work on it together.
Hey, Josiah, so if we are done with everything and everything's complete by Thursday,
Ex-
Thursday
Correct.
will be our last class.
Correct. Yeah.
All right.
Correct. Some of you will finish Thursday. Some of you may need to finish next week on, Monday, Tuesday, Wednesday. People will just be kind of slowly finishing at their own pace. We have 2 weeks before the, winter Christmas holiday, and that's when the month ends. So it'll all kind of finish at, and then here's an older announcement. If anyone's behind on past units, you can still finish. Just don't give up. Come join me every day, and I'll help you catch up. And like Manaya pointed out a moment ago, you're finished individually when you're finished, like with all the stuff from Unit 3, 4, and 5, or whatever it is. So some of you may finish this Thursday, which would be great, and then some of you may be finishing next week, and we have up until December 15th is like the end of the month. Let me put that on here. December 15th is the end of um, month 6. He's a little early. Let's see. Okay. Any other questions right now on like this plan for the class for this week, next week, please? No plan, no questions. Okay. As always, if you have any questions, don't hesitate to ask. So let's just review briefly the idea of standard deviation. And then also, I need to emphasize again the comparing data sets. And then I want to jump back in, everyone individually, but together as a group, to that Jamboard with the practice problems.
Okay. Hey, Josiah. Just quick question.
Yeah.
So what all do we have to do for this unit for it to be complete?
The mastery tests, and then at the end, the post test, and that's it.
Oh, okay.
The tutorials I'm only really using as like a backup, extra help, extra practice. So you don't have to do the tutorials. Only if, you want extra support in that topic because it's probably useful to hear it coming from another source besides just me. So um, when I was sick like a month ago or so, I was um, assigning everyone to do the tutorials that week. But that was just like because I was out. So all that's required are the mastery tests and the post tests. When you're in class with me, it's kind of like a replacement for the tutorial, if that makes sense.
Okay, thank you.
Absolutely. Thanks for asking. Okay, just a reminder, I've got my office hour. It is only 1 hour a week, which I know is not ideal, but it's what I have right now available. Tuesdays at 3 o'clock, same link, class link. So tomorrow at 3 o'clock, join me if you want extra help in anything from the class, not just Unit 5, anything at all. Come join me. We can do mastery tests together. Just go over examples, whatever would be best for you.
Wait, you said you're doing this when?
Tomorrow, Tuesday at 3 o'clock. It's every Tuesday at 3.
Okay.
Yeah. So all of you are welcome, and I really encourage you to come if if you need help on anything or just have questions. Also, we've got Brandon. A lot of you know him. Maybe you haven't met him, but I've been mentioning him. He's our math intervention specialist, our tutor. So you can work also with him throughout the week. Here's his email. All you got to do is write him an email and say, "Hey, I'd like to meet with you. What's a good time?" And you guys can work it out. If you want help with that, just let me know. But all you're going to do is write him an email or a Google Chat or something like that using that email. And his name's Brandon, and he'll be able to work with you probably every day if you want or need that. If you guys can work out a schedule. So let's see. Two things for today: standard deviation as a whole, and then also the idea of comparing data sets. So this is the slide from last Thursday. I want to use it real quick and go over these two ideas because I think in retrospect, thinking about it afterwards, I feel like I didn't do as good of a job as I wanted to emphasize like what the point was for when we last met, when we were doing standard deviation. It's kind of twofold. One, to just understand and use the idea of standard deviation. That was like totally new for us at our last meeting. It was the 18th, I think, Thursday the 18th. So I want to go over that. And then we also have to go over the idea of comparing the data sets. And basically that means choosing to either pick the mean or the median, mean or median, for the center to represent the center of data. And then also choosing the, what is it? I'm sorry, now I've forgotten. Also choosing for like the spread of the data, choosing either standard deviation or choosing the quartiles. So it's kind of a two-step process. If they're asking about the center, they mean choose the mean or the median. And if they're asking for like the spread of the data, then we're going to be talking about either the standard deviation or the quartiles for the spread of the data. Spread of data. All right, so let's start with the idea of standard deviation, and then we'll look at like choosing mean or median or choosing standard deviation or quartiles. So the idea of standard deviation. So here's kind of an idea of what it means. It's a number that every set of data has. And there's a long formula that we use to like find the standard deviation. But in this class, we're not going to be having to calculate it. We just have to be able to kind of use it if it's given to us. So I don't want to like freak you out or stress anyone out about actually calculating it. But I realize without doing that, maybe we don't. It might be not helpful to know like what it means and how we're using it. Um, so I was trying to strike a balance of being able to use it without having to, calculate it from scratch. So it's a number or a measure of how spread out our data is from the mean. So for instance, if we were given a set of numbers like this group of numbers, this data, we can calculate the median, right? By ordering them from least to greatest and then finding that middle value. We can calculate the mean by adding them all up and then dividing by however many numbers was in the set, in the data. Um, and when we do that, we're finding two different like center representations, either the mean or the median. But that doesn't really tell us anything about how spread out the data is. So the idea of standard deviation is this number of standard deviation gives us an idea of how spread apart the numbers are. So here's two examples that we used from last time. Maybe the numbers are more spread out like they are on the left, or maybe they're more compacted together like the dots I have on that graph on the right. So if the standard deviation number is higher versus like a lower one, if we were comparing two sets of data, then the set of data that is more spread out away from the mean would have a higher standard deviation than a set that's more jam-packed, more compact. So on the left, more spread out is going to translate to a higher standard deviation number compared to something like more compacted on the right, where they're closer to the mean on average. So the standard deviation is kind of like an average of how far apart all the numbers are from whatever the mean is for that set. When our data is a normal bell curve, like symmetrical, then we get these special percentage numbers with standard deviation. Put this in your notes. Draw a picture of this, or take a picture, like with your phone if you can't draw it today. It's sometimes called that name at the top, the 68, 95, 99.7 rule. when our data is normal or standard, like this bell curve is that we have here, then the mean is the number right in the middle, right here. And that kind of correlates to the very top of the curve. That's the mean right here. And then these values, these percentages of the data are grouped around the mean. So one standard deviation away from the mean contains 68%. Here, I'm going to cross these out. 68% of the data. 68.68%. And then two standard deviations away is the 95. It's on both sides. So we're seeing it go one away on the left and then a second one and then one away on the right and a second one. And then if we have a third standard deviation away from the mean on both sides, then it's 99.7%. These standard deviations. So in the problems that we're given and that we'll be working with, they're going to be saying like, they're going to be referencing those percentages. So your clue or tip off that we were using standard deviation when you're doing a math problem in this unit is if they mention any of these weird percentages, 68%, 95, 99.7, that right there is basically kind of telling you, oh, there must be referencing two standard deviations away or three standard deviations away or one. Standard dev. Now, every set of data has its own number for standard deviation. Let's look at one of these practices from last time. Actually, you know what I want to do? I'm going to use the first Jamboard problem. So I'd like everyone to do with me real quick. I will put this in the chat right now. I saw Braden and maybe someone else joined it earlier. Keep. I'm going to put the link for our Jamboard, and I'd like you to join me on the Jamboard because I'm going to reference those pages. And then you can also draw on it. Awesome. Delaney already joined. Here's the link. I'll put it into the chat today. You should all have it shared with you already. So if you click on the link, it'll take you there from the chat in Zoom. Or if you just navigate on another tab to Jamboard in Google, you'll see it there because you've already got it shared with you. You do have to be in your school account. It's been shared with like your OFY school account. And if you need help figuring that out, just let me know. I can get you your school email. So I see Delaney, Hunter, and Keegan. Awesome. So we're going to be flipping back and forward like in this Jamboard for practice. And I might go back to the PowerPoint as well. Aaron's here. Awesome. Good job. Braden, thank you. Now, there's another thing I forgot to mention last time, which was kind of embarrassing. I made a fifth page here. I think it's page 5. Yeah. it's kind of a cheat sheet. It's on the Jamboard, so you all have access to this. Um, and I wanted you to have access to it last time. It wasn't meant to be like a secret. I just forgot to tell you. So there's a little bit on standard deviation in the yellow and green boxes. And then in the remaining boxes, it's kind of like when we choose mean or median and when we choose the standard deviation or the quartiles, interquartile range to talk about the spread. So let's go over those real quick. So in the yellow and green, this is page 5 of the Jamboard. If you want to click to that, or just watch me on my shared screen. So the standard deviation measures how spread out the data is from the mean. And then in the green box, there's our percentages. So one standard deviation away on both sides is 68% of your data. Two standard deviations away on both sides, I didn't write that, but I'm applying it, is 95%. And then three standard deviations away is 99.7. So we'll need to use those values to answer some of these questions. And now for the remaining boxes. When they're asking us to choose the mean or the median to represent the center, we're going to use this blue box and the orange box. Let's see. No, just the blue box. So basically, we're going to have to calculate our mean and median and then compare them. And which one's bigger tells us which one we want to use. So if the mean is less than the median, then it's skewed left. If mean is equal to median, it's symmetrical and normal. And then kind of conversely, if the mean is greater, a bigger number than the median, then it's skewed right. So that means we've got a tail for skewed left. And a tail on the right for skewed right or skewed positive. In the pink box, choose mean to represent data for normal distribution. So if it's symmetrical and normal, then we are supposed to choose the mean to represent the center. And for skewed, so that's left skewed or right skewed, we choose the median. Choose median to represent data for skewed distributions. Because the median is closer to like the middle on the skewed sets, it'll be the one closer towards the middle. So the pink box is basically what to pick for normal distributions, normal or symmetrical. And then the orange box is what we can pick if it's skewed left or skewed right. Either way, then we're choosing median and we're choosing interquartile range for its spread. Skewed left or skewed right. Okay. So let's look at some practice problems. Let's see. Let's look at, we used this before, but we didn't have enough time to really do it all together. So I'm going to erase this work on page 2. Let's look at page 1 together. I'm going to just erase page 2 real quick. I only was able to check in with like 3 of you before we had to end class. I think I checked in with Delaney, Braden, and Aaron last time. Okay, so page 1. So page 1, we've got two different sets of data, it looks like, given to us in histograms. And they want us to pick which measure of center and which measure of spread we should use for each set of data. And then there's our choices in the gray box: the median, standard deviation, interquartile range, or mean. So just a reminder, the median and the mean, those are both what we would choose for measure of center. And then the standard deviation and the interquartile range, those are two options we could choose for spread. So on page 1, look at the Class A and Class B histograms with me. Can anyone tell me which of those two classes is normal distribution, looks like it's normal, and which one looks like it's skewed either left or right?
Class A is normal.
High five. Absolutely. Class A is normal. Can you tell me why you are picking that?
Because even on both sides.
Looks even on both sides. Perfect. Class B looks like it has a clear tail, so it's skewed. Very good. So I'm just going to label those quick: skewed. And particularly, it's skewed left because it's got the tail on the left side. And then above, we've got normal or symmetrical. Okay, so even though we're just eyeballing it, estimating it, right? We don't have the actual data, we just have the histograms. We can tell the shape: normal symmetrical on top, and then we've got skewed left on the bottom for Class B. So let's talk about the measure of center for each one of those. If we go back to page 5, our cheat sheet, and by the way, you all can use this later too. It's kind of like, think of it as like just a note sheet of the main points that I wanted you all to have from this lesson. So if we need to pick a measure of center for our normal and our skewed data, can anyone tell me what we want to pick for our measure of center for the normal or symmetrical? You can use the cheat sheet. Do I want to choose mean or choose median for my normal or symmetrical set? And I'll tell you what, let's do this. Instead of having one of you answer, let's do this. Let's try the chatterfall. So here's what I would like you all to try doing with me. I'm going to pose a question. I'll put it in the chat. For normal distribution, symmetrical distribution, do we choose mean or median? Now, don't answer yet, but I want all of you to type in your answer. And when I count to 3, you're going to hit enter or submit. And then we'll see all of our answers at once. Just come down like a waterfall through the chat in Zoom. Feel free to use the cheat sheet to find your answer. Okay, here we go. So I'm going to count to 3, and on the count of 3, I want you to hit enter, and we'll see everyone's answers at once. So for normal distribution, do we choose mean or median? 1, 2, 3. Go. Woohoo! Awesome. All right, high five to you 3 for answering. I appreciate that. For you And you're all correct as well. We want to choose the mean. So therefore, for our skewed set, we're going to pick median. Let's go back to page 1 and fill in our answers. Measure of center for the normal. Mean. And I'm taking this kind of from my answer box in the gray. And then measure of center for the skewed one on the bottom, we would choose our median. Okay, now let's talk about the spread. Because of the top set of data, the normal symmetrical, because it's symmetrical, we use the standard deviation to talk about its spread. We wouldn't want to choose standard deviation for the skewed sets because they're skewed, because the mean is pulled to the left or to the right. It's not right in the middle where we want it. So because standard deviation has those nice percentages, we can use standard deviation, the 68%, the 95%, the 99.7. Those are more relevant when it's a normal symmetrical. When things are skewed, then we'll use the interquartile range to talk about its spread. So feel free to use this page also as kind of a cheat sheet when we're picking which one we want to use. Okay, it's 10:37. Why don't we try this problem together? It's 3 questions in those bottom 3 boxes. I'm going to read through it real quick, and then I want you all to start trying them on your own, and I think we'll do them in Chatterfall style, just like we did for the last question. So Doug is analyzing the daily profits. This is page 2. Doug is analyzing the daily profits from the past month for 3 of his restaurant franchises. He has calculated the mean and the standard deviation of the data. So we're looking at his 3 restaurants, A, B, and C. And I guess this is the profits. So it's like how much he's made in his uh, for daily profits for the past month. And we're looking at the mean number of daily profits. So it's like he took all his day profits and added them all up and divided by how many. So location A made on average 6,127 and 85 cents. And its standard deviation is that 413.51. And likewise for B and C next to it. So question 1 is talking about average. So they mean, are we choosing it's referring whenever they reference average, they're saying either mean or median. Now, this problem isn't giving us any information about the medians, right? So it's really just a code word for mean in this case. Its median is kind of eliminated because there's no information about it. So basically, it's referring to mean. So can anyone? Well, let's not do anyone. Let's do the Chatterfall. Take a moment and see if you can answer this question, and then I'll count to 3. We'll put our answers in the chat box. Which location, A, B, or C, had the highest average, highest mean daily profit during the past month? So just type in A, B, or C. And I'll count to 3. Okay. So A, B, or C, which location had the highest mean average during the past month? We'll go 1, 2, 3. Go. Awesome. Thank you, you three. Anyone else? Please put your answers in. All right, Aaron, Keegan, Delaney, high fives to you three. Yes, absolutely. B. Good job. We're just comparing which one had the greater mean number. And they're all pretty close, 6,000 and change. But location B has the highest mean, 6,200. And the other ones are 6,100, 6,100. All right, now for some harder questions. For which location does 95% of the data lie between these two values? And they tell us that's 2 standard deviations away from the mean. Remember, 95% correlates to 2 standard deviations away for normal spreads. To figure this question out, we would need to figure out what is the spread or the range 2 standard deviations away from each of the three locations. Now remember, standard deviation is going on the left and right, low and high, away from the mean. So for instance, let's do the first one together, location A. I'm going to do it on my screen. So for location A, I'm going to make a little model of it just to kind of keep it in order. So I'm just going to say this must be what location A's looks like. The mean right in the middle is 61, 27, 85.85. And then 2 standard deviations away on the right, that's like adding 413.51 twice. 413.51. So I'm just going to use my calculator. 6127.85, and then add 413.51 twice. So 2 standard deviations away on the right puts me at 6954.87. Okay, now I want you to help me do the second part. We'll do Chatterfall style again. So now what we're going to do is subtract to figure out that lower boundary. We want to subtract 413.51 from the mean twice. So it's kind of like my 61, 27, 85, the mean minus 413, 51, and then do it again. So I know I'm asking a lot. We're doing some actual math on a Monday morning after Thanksgiving, but I believe in you. You can do it. We'll do it Chatterfall style. I'm going to give us 10 seconds to try to figure this out. And then those of you who are willing to try, I want to hear from you in the chat. I'll count to 3 in 10 seconds, okay? So question is, what is the low range for location A's 2 standard deviations away? Okay. So I'm going to count to 3 and we'll do the Chatterfall again. 1, 2, 3, go. I must have lost you. So let me show you what I mean. I must be not asking my question very well. We want to find this lower range of 2 standard
Hey,
deviations.
Josiah.
Oh yeah, go ahead.
I didn't hear your question. The only thing I heard was must have lost you. That was the
Oh,
last thing I heard from you. I did not hear your question.
oh, sorry about that. Thanks for telling me.
You're
Um,
welcome.
The question is, what is the lower boundary of the standard deviation of location A for two standard deviations? So I did the higher boundary on the right here. And how we find it is by taking the Delaney, yes. So I asked a poor question. I didn't ask it very clearly, but that's what I'm asking Delaney. Correct. We take the mean. I'm going to write it out, kind of the process, and then we minus standard deviation, and then minus it again, and that would find yes. I think that's correct. 2142.15. Let me just confirm it with you. So I'm doing 6127.85, and then I'm subtracting its standard deviation, 413.51, and then I do it again a second time because it's asking about that 95%. That's 2 away, so I have to subtract it twice. Um, I think okay, Delaney, I think you did the right thing, but we just didn't use the decimals. So instead of getting that negative 2142, you'll get a positive number. What we're subtracting is 413.51, 0.51. So you subtracted out like 4,000. Let me write it out here, folks. I'm glad you see it. Okay, so here's the math that I'm doing. So the mean here is 6127.85 minus its standard deviation, 413.51, minus it again, 413.51. Okay, so sorry about my question. If everyone wants to try that for me, we'll compare our notes. Okay, we'll compare our answers. So 10 seconds, try doing that subtraction, and I have it on the screen. And I'll count to 3, and we'll see if we all get at least something. It's okay if we don't all get the same thing. We're just doing it together for the first time. Let's give it a shot. Okay, here we go. 1, 2, 3, go. Delaney's got something. Thank you, Delaney. Anyone else find it or find some answer trying it?
I got the same thing as Delaney.
Manaya and Delaney, high five to both of you. That's what I got too. 53, it's 5,300.83. So what we just found was two standard deviations away. Let me put my little lines in the picture here. Two standard deviations away for location A ranges from that 5,300 number, 5,383, all the way up to 6,954.87. That's the first one I did. So, long story short, to answer question 2, back in that box, we've ruled out location A because the range doesn't line up with the range they were asking about. So the process we would have to do now is basically start over, trying it for location B, and if that doesn't work, we try location C. I'm going to go ahead and jump to location C, and let's see if that one works. So I'm just going to make a little picture to model so I kind of keep track of it. So here's C's picture. The mean they gave us is 66,191, so 6191.28. Then we would do the same process again. Its standard deviation is different. It's 330.83. So on the right side, we want to add it twice. I'm modeling it here. And on the and on the left side, we want to subtract it twice. So minus 330.83 minus 330.83. 83. I know I'm writing kind of tiny. Forgive me. Just running out of room. So I think C might be our answer just because we've already used B and we've ruled out A. We tried doing A. So let's confirm that it's C. Let's check this together. So I want you to take a few moments, try to find both the low and the high number. Oh, I think I've got something coming in. Is that Delaney again? Yes. Thank you, Delaney. Keep doing it. Do the high number now. I think you found the low one. And don't just let Delaney do this. I want you practicing it too. So I'll write out the kind of the process that we're using. The mean, and we're subtracting. To find that low value, we want to subtract the standard deviation twice. 6191.28 minus the standard D twice, which is in this case the 330 number. 330.83. Don't forget your decimals. Minus 330.83. So let's do the low one and then we'll do the high one. I think Delaney already answered the low one, but let's double check. And I want you all to put it in the chat. We'll try it out together. So first, here, I'll put my question in the chat. What is the low number? What I mean is 2 standard deviations away from mean on location C. And I'm going to count to 3, and I want to see what you guys get. It's okay if we don't get the same thing. I just want to see you trying. All right, I'm going to count to 3. 1, 2, 3. Thank you, Delaney. Did anyone else try it? No one else tried it. No. Okay, let's try the high one. Maybe Delaney already found it. I'm not sure. I want you all to try the high range number now. 2 standard deviations away from the mean, location C's data. So I'm going to model it below or on the screen. So mean, add the standard deviation twice. This is our high number. We'll count to 3 and we'll see your answers. Okay, here we go. High number this time for location C. 1, 2, 3, go. Woohoo! All right, Delaney, you get the star for today. I guess I need to do some online stickers or something, a reward system. Nice job. Thank you for doing that and trying. And for all of you, but if you're, I wish I could hear from all of you and see your attempts, your work, like Delaney did. But yeah, good job. So you basically confirmed, Delaney, that location C matches this scenario. So I'll write that there. 2 standard deviations away puts us at 5,529 and then 6,852. Now, I've run out of space to draw, but for the third and final question here, it says, for which store does 68% of the data lie between this range? And then it's because it's referencing 68%, that's our clue that they're talking about one standard deviation away, left and right, low and high from the mean. And then they give us a little hint too. They tell us at the end, one standard deviation away. So this process would be the exact same as what we just did, except we're just adding and subtracting the standard deviation once. Now, Edmentum, I think, is only going to use each location once as an answer. So it's probably location A, right? As a test taking strategy, I'm thinking I've used B, I've used C, it's probably A. But let's confirm that. Let's make sure the numbers work out. So can we find the low? Can we find one standard deviation away? It's in the chat. Find one standard deviation away from mean for location A. We want the low and the high number. Okay, I'm going to count to 3, and then I want to see your answers. Again, it's okay if we don't get the same thing, but I just want to see you trying. Here we go. 1, 2, 3. Good. You found the low one, Delaney. Double check the high. Does the high one line up with what they're asking in question 3? Yep. Okay. Very good. Thank you. It's almost time to go. I need to double check who's here and who's not here. Okay, so I think today went pretty good. We probably all needed a little refresher on standard deviation and stuff. So tomorrow, I wanted to start the new material. I think I want to do a little bit more review on standard deviation until I'm getting more feedback from all of you on it. Okay, so we'll probably do a little bit more in the Jamboard tomorrow and then start the last lesson.